Alright, in this exercise we will get introduced to the mold making workflow in Solidworks, and we are going to make a simple two-piece mold, so the cavity and core mold for making a part. It is very important that we have an object with a drafts, and for our casting purposes and for the surface roughness of the 3D printed part I will go with a minimum of 5 degrees of draft angle. So as we discussed, we will make the small shot or a small glass project, and I'm going to make it as a, maybe actually I will just make it as a revolved object, a very simple one, because we are going to really demonstrate the SolidWorks. So to make the glass, it's a revolved object, I'm going to make something that looks like a trapeze, and I'm going to make the center line, and I'm going to make this piece to be a fairly small dimension. Like in a height I will put it to 1.5 inch. The bottom diameter I'm going to put to like a 1 inch, and the top diameter I'm going to put maybe for a 1.5. So that will be kind of the outline of the contour. Now, what I'm going to do, I'm going to revolve and create something like this. You see that I intentionally make it to be full. I did not hollow it, I will use shell command to hollow this thing. Now, I will put some fillet. Because plastics doesn't like sharp edges, I'm going to put the fillet of 0.125 or 1/8 of the inch, and I will put that fillet at the bottom. And let's say that this is my very simple cut. Maybe I don't like it, maybe it is a too shallow, so what I can do, I can go back and edit my proportions, and maybe I will make it to the 1.0 from 0.75. Let's see how that will look like. Will it look a little bit better? Okay, that looks a little bit better. So it's a really tiny 1.5 by 1 inch. So if we look into the, that's about the size of the shot. Okay, 1.5. And the diameter is going to be a 1 inch at the top. Now, what I'm going to do next, I need to hollow this object, so I'm going to do a shell, and I'm going to keep at least 1/8 inch thickness of the wall, and I will take out the top shell. And I'm going to make another fillet inside. Okay, so it is obvious now that I can actually pull this out, okay? And I will call this cup example. And save this inside my directory for the NPD103. I will define material as ABS like. Now the question is, can I actually produce this by casting? And the answer is definitely I can. And how I'm going to move from this into the casting, I'm going to save as cup example mold construction as a separate file name, and I'm now going to start building my mold. I'm going to sketch on a front plane, on a top plane. I'm going to sketch the outline of the mold. And I know that this is a 0.75, so I will put that I need at least a 0.5 inch on the other end. So I will put this port to be a 1.5, and I'm going to put it at this direction to be a 1.75. That will be the size of my mold that I'm going to make. So now the first step that I'm going to do, I'm going to insert mold folders. So mold is always generated in a Solidworks as a multi-body object. And then we will extract, flatten, and convert them to an assembly. But how the Solidworks generate it is as a multi-body object. So I go to insert molds, and I insert mold folders. And that initiates Solidworks to be able to perform certain operations. As you can see, we really didn't see any changes here, but the Solidworks is now able to start doing the molding. The first thing to do is to analyze the parting line. Mold parameters will be a surface upon which we want to open it, and the surface or a direction of opening the mold will be obviously this one. And I can also click on a split faces for the draft analysis. Draft analysis will produce me the parting line. And what is the parting line? The parting line is a line where the two molds will close, really, where the core and cavity touch each other. So parting line will define the parting surface. Okay, and the mold can be separated into a core and cavity. As you can see, the parting line has been inserted into the Solidworks parametric tree. The next thing that I will do is to extend that parting. We don't have a shut-off surfaces because we do not have any holes. Shut-off surface we use when we have a hole, and that will be for our mold number 2. So the next thing that we will do is parting surface. Parting surface, if I click on the option, and I want it to be a perpendicular to the pool, and knit all surface, show preview, and let's click OK, and let's see where is my parting surface. It is created, however, the extended of it is very small. So how about if I increase the distance of the parting surface and I change the direction? I can make it as large as I want. It just needs to be outside of the scope of the mold. The smoothing, if we have a complex geometry, is how actually the edges of the object will move. Okay, I will click OK. So I have now this big parting surface created, and as you can see, the surface body. Now we have the cavity body surface, we have a core surface body, and we have parting surface. Now, the next step that we will do here is to extract core and cavity, to extract the two pieces. The template for the core and cavity need to be a sketch. I did this simple sketch here of this rectangle, which I will use as a template for the overall size of the mold platens of the core and cavity. Okay, so I will go now to the tools. I will go back to my mold, to the insert, back to the mold, and to extract this is called the tooling split. Select a plane or planar face or an edge on which to sketch the feature cross-section, or an existing sketch to use for the feature. We are going to choose the existing sketch. And as you can see, it has recognized a certain, and now it is asking us for the block size. We can also click on the interlocking surface, and the block size is the one, and another. thing is that we need to move the okay, another thing that we need to do, that sketch need to be coplanar with my parting surface. So if my parting surface is at the, let's see, my parting surface is at the, not at the top plane, but I will need to create a plane which will be coplanar with a parting surface. So I will create a plane, reference geometry plane, which will be coplanar with a parting surface, or I can use the edge to point the edge, and it will fully define my new plane. And now if I move this sketch below, I can right click on a sketch and I can change its top instead of the top plane. I can choose my plane one. And I move the sketch there. Now I can insert molds, tooling split, and I will just go maybe 0.25 in one direction, and in the opposite direction I will go with 2.0. That's too much, maybe a 1.75, because the 1.5 is the total height. Okay, so now what we'll create, I will have two blocks here. And those two blocks will contain, you can see that now I have three solid bodies. There are now three solid bodies, and for this simple mold, this will end the creation of the mold platens, but we will now have to do something with those platens. So if I look into the solid bodies, I have a parting line which is my original solid body. I have a tooling split one which is my core. I right click on a tooling split one, and then I left click on to insert it into the new file name, and I call glass, well, what will be this, cavity, or cup cavity, cup cavity. Click OK. Look what I got. I got cavity automatically done. Now I go back to my construction mold window. I will do the same things for the core. Core is the male parts. Okay. Right click on the tooling split tool. Now go down, left click, insert into a new part, and I will call here the cup dash core. And look what I have. I have the core. Now, I have, those are just like kind of the templates of the shape itself. What I will need to do to convert this into the mold that will be a functional mold, I need to have some way to index these two together, to hold them, to clamp them all together, and a way to bring in the material into the cavity, which is into the molding voids or cavity which is formed in between the mold core and cavity. So I will need to create a system of the razor and sprue for casting, and I will need to have some bolts or some other way to keep it together, and I will need to have some alignment structure, what I'm going to design next. To design those, we will actually go now and make an assembly of these parts. So we are going to make a new assembly, and we can start with, for example, this component. So file, make assembly from part, make with the core I will start. Now I'm going to insert another component, and that will be a cavity. I will insert it somewhere else. I'm going to mate the three to center this. So I will mate this side and this side, click OK. I will mate this side and this side, click OK. And I will mate those two. Yeah, and you can also see here that they end this one. And as you can see, this is now fully defined assembly. Now, what I can do, if I look into the cross section, look what I have inside those bricks. I have actually the air pocket, which is in the shape of my cup that I want to start casting. So, what I need to create now, I need to create a way to bring the material in, and usually you want to bring the material in to the lowest point in the mold. Why? Because you want the air to be displaced from bottom to the top. At the top, I'm going to make some vents which are going to let the air to get out. And then I will need to make some, let's say, 4 or 3 holes, which I will use to align and also to hold this mold together. Okay, so now in the first part of this exercise, let's make your oven cup. It doesn't need to be a cylindrical. It's okay if you repeat this, but it can be any other shape, as long as it is as long as you can pull, you can separate core and cavity.